Okay. Hey, folks. Thanks for coming. This is the very first meeting for Upstream OLM Feature Planning as part of the operator framework. So we set up this meeting with kind of the goal of uh, making the Upstream project be more out in the open so that we can actually sort of describe what the release cycle will look like, and hopefully kind of define things a little bit better so that everybody knows what's coming down the pipe, and B, if they have anything that feels like it's really pressing and probably actually needs to be part of a release, that we can kind of talk about those things and come up with at the very least some kind of triaging method for feature requests, and as well as if anybody's interested in doing any work on OLM, the ability and the knowledge to know what's actively being worked on so that they can pick stuff up. So I'm going to, just before we even get started at taking a look at what our milestones and sort of release process looks like, the proposal that we have currently is using a milestone-based release tracking process. So right now, OLM has kind of an opaque way of defining when we do a version bump and when we cut releases. So the first goal that we sort of have is make that process more obvious. We're going to basically do that by, well, we have kind of a couple of different ideas. The thing we're going to try right now is we're going to start tracking issues in our GitHub repository, and anything that we're going to tag for the next, we're going to either tag for the next upcoming release. So that looks to be 0.17.0 would be that release. We're going to tag a set of issues related to that. And so once everything there is accounted for and merged, that's when we'll cut a release. Anything else that looks like it's not going to be prioritized as specifically part of that release, but looks like something that's probably valuable and something we need to continue having discussion on, we're going to tag as backlog for now. So that's going to be kind of the goal for today. Is we're going to take a look at issues that are already tagged for 0.17.0, and just make sure everybody's on the same page there.
So just to make sure I understand, so you want to use issues in the OLM and the Operator Lifecycle Manager repo to track RFEs now, and do you also want to use? So I guess you should probably come up with a convention on how you want to do that. I've seen that Alex has created a few out there. So I think that's great because I think that makes it much more transparent and easy. For things that might not be completely architected, like the enhancement PRs, which are much more deep. And then how do you want to deal with the operator registry repo? Do you want to handle those at the same time? Or I think that needs to be managed by the same team.
Yep, it is. That is the goal. So that was going to be one of my next talking points, which is I think we want to do the exact same thing with the operator registry. It's not included. So just so you guys know, Alex, who is not here today because he is off on PTO, was normally going to be running this meeting. So I'm taking over for him. He set up most of the discussion points on here. I have one more to add, which I didn't have time to go and link in the meeting agenda, which is on the operator registry. And so the version, I think, that currently is in the operator registry is 1.14. So we're going to be tagging anything that we're calling the upcoming release operator registry as 1.15. I only have one big one, which is a pretty meaty issue that we're going to tag for that. And we can discuss that later as well. Okay. So the only other thing I want to mention as part of our milestone tracking is I think one of the things that everybody who's been working on the OLM project for a while now sort of wants to do is, and I don't think we're going to necessarily solve this today, but I think what I'd like to put out as sort of a thought bubble for everybody is I think we'd like to come up with what are sort of the things that we want if and when we actually create a 1.0 release of OLM. And so I don't want to tag anything today, but I think hopefully as we do a few iterations of this meeting, which is currently scheduled for every other week, we can start trying to flesh that out somewhat. And hopefully we can create some issues that will, sort of define what the structure of 1.0 would look like, and then kind of plan what that would be from there. So let's move on. I think what we want to do next is let's look at OLM first. Let's take a look at all the issues that are currently on the OLM backlog, which currently have let's see if I can find the milestone, 0170 label attached to them. So I'm going to go bottom up. Let's start with 1783. So this one, if you're not already familiar with it, so the RFE is installed operators can expose a communication channel with OLM. So specifically, we're targeting update readiness as sort of our initial use case for this thing. There's already a proposal that has actually been merged. So this one's fairly far along in terms of what the implementation is going to look like. There has recently been a little bit of churn. I think there have been a couple of additional PRs open in the enhancements repo to update that. So take a look at it. But the high level idea here is that we're going to create a new CRD that will allow operators to define whether or not they're actually ready to upgrade. So specifically, this is to handle, like the original goal was specifically to bubble up a status of, hey, I'm a database operator, and I'm in the middle of doing some kind of database migration. If you kill my pod right now and update to another version, that could be problematic for me. So I need you to wait until I'm done, and then once I'm done, then I'll signal to you with the CR, and then OLM can go and kill and do an upgrade. So does anybody have any thoughts or questions around that?
No, that sounds good.
Okay, all right, sounds good. Let's move on. So 1784, this is one that I think has been a long time coming. We've been talking about this for quite a while. It's very straightforward. So ever since OLM and the rest of the operator framework have been donated to the CNCF, technically right now, the operator lifecycle manager repository, as well as the operator registry repo and the operator framework API repo, all of those things technically also drive the downstream OpenShift product. And they've got a lot of bits in them, which are specifically aimed at OpenShift and deploying OpenShift. So the goal of this RFE is to split all of that out. I think the plan at the moment, so there is a PR that I believe was just opened up a day or two ago. I can go and take a look and try to find that in the enhancements repository that describes the process there. I think we're pretty close to the point where we know what we're going to do there. But the goal is basically to take the existing operator framework repos, and from the perspective of the upstream community, we're just going to strip out all of the OpenShift specific stuff. There is going to be some work on our side, so it's not going to happen overnight to set up. So one of the biggest things right now is that all of the automation and merge workflows that are in the upstream project use downstream OpenShift specific tests and test infrastructure. So we're looking at replacing that with Upstream Cube, so that we're not gating on OpenShift specific requirements at all. And then I think the other part of that work is just there will probably be an open source repository or a set of repositories, depending on how we decide to set that up in the OpenShift repo, or in the OpenShift org, which will basically be some kind of mirror for the upstream stuff. So that's the idea. Does anybody have any thoughts or questions on that one? Okay, cool. This next one should also be really, really straightforward. So we're just going to bump our current dependencies that are in OLM and the registry to cube 120. They're currently on 118. We still haven't bumped to 119, but I think we're going to skip that release and go straight to 120, just based on mostly the lateness of the 119 release, which I think just came out very, very recently. So I think that's kind of the goal. As soon as 120 drops, we're probably going to pick that up. Any thoughts?
So do you have to be concerned with, so we're going to have some, so we're going to run into bugs and so forth with older OLM releases. Are we going to have multiple branch strategies to support, you know, the previous versions of the Kubernetes componentry and the newer ones? Because I think there's breaking changes, right, that are there.
So from the perspective of OLM, as far as I know, the only real breaking changes that we're going to see are in, I believe, the 122 release, which deprecates removes the V1 Beta 1 CRD version.
Right.
So I that's a good question. I think that's probably something we as a group probably want to explore and see what we can do to make that happen. Right now, OLM doesn't do that at all. We just always release forward. We don't actually like pull patches down to older releases. I think that's probably something we should do. I don't have a specific strategy for it today right now. Does anybody have any thoughts about how we would want to approach something like that?
You probably want to do just define what your strategy will be upstream. Downstream will always have a different one, because I think the downstream will always be like whatever the OpenShift support policy is. I think the SDK does N-1 releases. Joe might correct me if I'm wrong, but so basically if we do 1.0 and then we do a 1.1 and then we do a 1.2, 1.0 is no longer supported.
So here's a question. How frequently do those minor releases ship?
We're defining the release process now. We've kind of toyed every 3 weeks, every sprint. I don't remember, they announced, I think it's every 3 weeks now. As of yesterday, they were talking about doing a 1.1 release in about 2 weeks and then starting the cadence of every 3 weeks from there. So it's fairly quick.
Mm-hmm. Yeah, that makes some sense to me. I think from OLM's perspective, we probably churn a lot slower than that. I'm now.
And you can do it, and however you choose. You know, you can pick minor or major. You could say we support. You know, it doesn't have to be. You know, N-1 major releases or N-1 minors, and then if you're doing individual like patch releases every 3 weeks and every 6 months is when you're doing a minor, you know, but you can't do it, I don't think, the same level of support as you do downstream. I don't think it's sustainable.
So I think maybe what you need, Kevin, is an RFE to establish the cadence on how you want to build OLM and deal with it. So I think you need the governance RFE.
Yeah, I think that makes a lot of sense. I think that we probably want to just go and write that down. So actually, here's a question for the call. Does anybody want to take that as an action item and come up with an initial set of like what our release cadence is and the things associated with that? I think what we're doing here is we're describing a process for how we want to handle deciding what goes into those versions. And so my imagination is that we're going to do something like a minor release every 3 months. That's usually been about our cadence if you go and look at historical version releases, but we're not super consistent there. So we probably want to establish something like that is my guess. Does anybody have any thoughts there? Anybody want to take that on?
I mean, I think, yeah, I guess I don't want to do it because I just don't have enough background, but I just want to say, I think that's a good starting point. But I think you should also include, your policies and for compatibility and all that kind of stuff, whether you're following the Kubernetes mechanisms or the CNCF governed mechanisms, the OpenShift ones, because they're all a little different.
Yeah, that makes sense to me. Okay, so why don't I'll take that one as an action item. I can write up an initial version of this and create a PR, and then we can all continue to discuss it there. Does that make sense to everybody?
Perfect. Thank you.
Okay, cool. All right, does anyone, moving back to cube releases, does anybody have any strong opinions on those? I think for what it's worth, the 3 months that I just sort of threw out there just now is kind of based on the cube release schedule because they generally try to release once every 3 months or so. So if we have our minor releases might line up somewhat with cube releases, I think that basically every single minor release milestone will probably have one of these RFEs related to bumping the cube version.
Yeah, as long as that includes evaluating breaking changes and any downstreams or any side effects, right? So I think moving up totally makes sense as long as there's no adverse side effects, right?
Yeah, no, I think the reality is that no matter what, we're going to have to deal with that. So
Yep.
like being aware, I think that's basically what this RFE is we'll need to go and look at all the cube release notes, see what's changed, see if there'll be any problems with any of our users, and then make choices and recommendations based on that. And if there are breaking changes, then we need to announce those and be aware of those and have a mitigation strategy around them.
I think another thing that, and maybe you're getting at this a little bit, but another thing to be aware of is breaking changes within a cube release, like OLM breaking changes within a cube release minor version. So if we're only going to release once every 3 months, does that mean we're also not making any breaking changes within one of those minor releases ever? OLM breaking changes.
Yeah, that's a good question. So right now, because OLM is a 0.x release, we just have not been following strict policies around breaking changes. I mean, I think we attempt to avoid them wherever possible, but we haven't used it. But I mean, if you look at the mechanics of semantic versioning, staying on a 0.x release is basically why we continue to do that. So I think once we actually have a stable release, that's going to be when we have much more strict policies around how do we bump the major version. And basically bumping major version means some kind of breaking change has occurred.
Do you think that, so even staying on 0.x releases, has OLM in the past, and do you think, at least for the immediate future, that there will be breaking changes on the Z stream, like 0.
No. So whenever we introduce a breaking change, that's when we'll bump the minor release.
Got it. So that's what I'm kind of getting at is that kind of means that only breaking changes can happen once every 3 months when there's like align with Kubernetes releases. Is that what you're saying?
Yep.
Okay.
Yeah, I think that's the idea.
Cool.
Yeah, and I think that's probably an important and fair thing to call out in whatever governance and versioning pull request I create when I go and look at it. So thank you. That's a good point. Okay, let's move on. So 1786, allow cluster admins to see what is installed as a dependency. This is specifically around, so we shipped the new resolver in 1.16 or in 0.16. And so as a result of that, the model with which OLM is deciding what to choose for an operator or for an operator dependency has gotten more complex because of the fact that there are more choices for the resolver to make, and that the resolver is also using more information than it was before in order to decide what to install. So I think one of the fallouts that we sort of knew was going to happen and we'd like to improve upon is when you have installed something, how does a cluster administrator actually go and look to see why the resolver made the choices that it made?
So this is mostly looking at a post-mortem rather than a dry run, right? Of what's possible is what already happened, right? Is that what you're saying?
So yes and no. I think yes, in the sense that if you're using the automatic update scheme, which is sort of like the default way to use OLM, that yes, this is like after it's already happened, here's what it did. But I do think that there's a little bit of leeway here, and probably something we need to look at and discuss as a group, which is if your subscriptions are in manual mode because you're manually approving install plans, but if, for example, we decided that this information needs to sit on the install plan itself, that in theory, if you knew that, you could see like, oh, hey, here's what the resolver decided on, and that's what I'm like, that's what I that's what I'm going to get when I approve this install plan. That being said, I don't think what we're talking about is okay, so the install plan has some stuff in it, go and like make changes to that install plan to pick different stuff instead. I don't necessarily think that we're talking about an opt-out here or like a manual modification here. So it is just logging essentially.
Yeah, okay. I just wanted to make sure. So it's basically a read-only view of the dependency world, but as it is now, and then potentially how it could be depending on what you know, right?
Right.
All right. So, all right.
Yeah, I think there's some more steps on top. This is like step one of making the resolution more understandable, and hopefully when we have that information more explicit, right? Like the follow-up for that could be in the future something like, oh, and now, like, I'm just throwing out ideas, right? Like, I'm not saying that that's exactly how it will work, but for example, you could do something like, okay, let's actually go and make install plans writable so that you could like overwrite something. Or maybe it's something on the subscription where you could specify like a subset of resolution requirements because the resolver now can go and look at what's on the cluster and make choices based on that. Whereas before, all the resolver was doing was it was just looking at the catalog and applying stuff.
No, it makes sense. This would be an awesome one.
Okay, cool. Anybody else have any other thoughts?
I think with the, sorry, I joined kind of very late into this discussion, but looking at it, it seems like a very sensible thing. I know that with what we're doing, we're using operators in the Cloud Pak for integration. We have a lot of dependencies, and being able to clean things up is a question we get from a lot of users. How do we then take everything away again? this is the kind of information that helps that happen, right?
Yeah, no, that's a very good point, because once you know exactly what got installed as a result of this thing, I mean, you still get some of that right now with the install plan. It's just sort of hard to read because there's so much information there, I think.
Yeah. No, that's awesome.
Yep. Okay. All right. Moving on. So just one more, which is OLM deletes operands upon operator removal. So this is an opt-in feature. Basically, the idea is right now, OLM purposefully and explicitly does not delete any cluster state as a result of deleting a CSV or a subscription, right? In fact, if you go and remove a subscription, it doesn't even delete the CSV. You need to go and do that yourself as well. But this is more about CRDs and the CRs associated with them. So the idea here is basically that an operator who would prefer that workloads are removed when the operator is deleted, or as a cluster admin, I actually want to explicitly say, hey, go and delete not just the operator, but also delete all the associated workloads, because there's basically the case, which is the operator is the only thing that knows how to clean up resources. For example, if it is creating something outside the scope of the cluster, or even if it's inside the scope of the cluster but isn't associated with, like the operation of removing it is non-trivial, and the operator itself needs to have the logic around deleting it. So the goal here is basically have a signal that when you delete the operator, first delete all the CRs, wait for the operator to use finalizers or however else we want to implement this, clean everything up. Then once it's finished, actually remove the CSV, delete the operator, and then basically you're in a better situation than you were before if you want to force that.
Makes sense to me.
I'm just trying to think of if we would want to use it. At the moment, I doubt that we would want operator removal to remove any of the services that we install. But I can definitely see use cases, especially like you say, with things outside of the cluster. And if we ever use finalizers, then you can't delete the items without the operator, really.
Right, exactly. Yeah. So I think the use case here and the driver for this is kind of, we've seen some operational teams who, when in the scope of using their operators, are building things like AWS resources, for example, and cleaning those things up without knowing where they came from is a very difficult and cumbersome process. And so just having the option to opt in to forcefully delete all of that stuff and clean it up as well is kind of like the goal.
So the opt-in bit, I don't think is clear here. Are you saying that an operator would decide to opt in to always clean up its resources, or are you saying that when a user goes in to remove an operator, that they would then get the option to also delete the CRs?
So I think there are actually two parts. The first one is that an operator needs to define itself such that you can actually go and do this thing, right? Like it's one thing to us for the if the operator just doesn't know how to go and clean up all of these things by implementing finalizers on all of the associated resources, there isn't a lot that we can do, right? So the operator will need to opt in and make this feature available for a cluster administrator. And then in addition to that, we're basically going to have to create some kind of -- force operation. I think we still need to figure out what the UX for that looks like exactly. But the cluster admin then knows to be able to opt in to use that feature the operator is making available.
Yeah. I mean, I can see it being useful both ways, but I'm trying to think. Yeah, it's one that's tricky because it could be dangerous if it's implemented in a way that surprises people.
Yep.
But yeah, I can see you've thought about that already.
That's why it has to be really specifically, you really need to opt in and really know what you're doing if you want to actually have this feature.
Yeah, absolutely.
Yeah, having a dry run kind of capability in here would be super helpful too, right? being able to at least like visualize, which is kind of the previous one, what all the resources that were created, by this thing, so you could actually get a collective understanding of that.
You mean all the way down the dependency graph, so all the way down through the deployments and the pods and the secrets and the everything else?
You kind of want to know when you installed something, what is owned by me, right? What did I create as a result of this, right? From an audit perspective, even. And so,
and you kind of get that already from the resources of installed CRs, but I suppose there isn't necessarily a single view where you can see the whole tree. You can only see the tree for a single CR.
So I guess what I'm suggesting for this is, if you did a removal, could you do a mock removal?
Yeah, so I think if we were to implement something like that, we would need to have a view, like the operator would need to tell us, hey, here's what I built. So here's what's going to be removed if you go and do that thing.
Yeah, I mean, a lot of the stuff you can get with owner references, but anything outside the scope of the cluster or anything
or
that
namespace or cluster scopes. Yeah, exactly.
Yeah.
I mean, I guess I'm after breadcrumbs, right?
Yeah.
So even if you opted out, at least have the log say, this is what I didn't do for you. So you can do this at your leisure later on.
Yeah, that's putting, I know that's not something OLM can do. I think that's something that would have to be specified, and then operators would have to implement, as well as OLM implementing the ability to collect that information.
Right. Totally agree.
Which makes it hard. Doesn't mean it's not valuable, but it makes it hard, I guess.
I'm just talking about the possibility. I agree, it's hard.
Yeah, it seems like if we wanted to do something like that, that would actually almost be more like part of the operator status object that we talked about earlier, right? Like if an operator had a way of describing, hey, here's my state, here's all the stuff I have created declaratively, so that we could OLM could read that thing and try to infer based on a set of metadata, like what will be removed when you go and do this. But again, even then, you would need the operator individually to opt in and, A, declare that, and B, declare it correctly.
Yeah.
Okay. Anybody else have any thoughts? Okay. So that's everything on the OLM board. I have one I'd like to go over quickly on the operator registry side, which I threw up literally just as this meeting was starting. So I think this is something we've been talking about for a long time, and we want to target it as part of the next OPM and operator registry release. So today, right now, the way that the registry works is you add a bundle, and that bundle has some metadata about how to install that version of an operator to an index image. And by doing so, you've now updated that index image with extra, like, here's my one new version of my package. Now go publish this version of the index, and it includes all the history plus that one new thing. And that is really, aside from a couple of sort of extra commands, the only real way to define everything that exists in the registry itself. So that's the only thing that can serve. There's no way for a user to, like, for example, modify package level information, like what is the set of channels, or what is the default channel for a package, or I want to remove this specific version, or I want to modify the set of edges so that you can't install from here to here. Right? We just don't define an interface for a user to be able to do those kinds of things. And it turns out there's a lot of requests from a lot of folks around, hey, I actually want to modify this specific thing outside the scope of publishing something new. Or, hey, I just actually want to remove this bundle from my edges, and I don't want to have to worry about that thing getting installed ever. So I think the goal here is the churn on the UX of this command line tool is basically going to make that impossible if we have different commands for every one of those. So instead, what we're talking about here is building something which the entire index can be defined by here's a blob, which is the set of metadata that describes the entire the whole thing, and all you have to do is pull that thing out, modify it, whether it's a JSON object or whatever else we want to define it as, modify it in some way, and then push it back in or generate a new image wrapper for that thing. And by generating that interface such that it's human readable and machine readable, that kind of covers all of the use cases and requests for, hey, I want to modify my metadata outside the scope of adding bundles.
So this also handles being able to modify like a default channel of a package.
Yes, that would be an example of one of those kinds of requests.
Yep. So what do you want to call the milestone for this one? It's like one dot.
I believe
your documentation here.
Yeah, let me double check. I believe we're on 114.3. Yeah. So the milestone here would be 115. So yeah, that's the only one I wanted to bring up for operator registry. I think we're going to basically follow the same format for what we just described in OLM for the registry project as well, just with different version numbers.
Yeah, I kind of like the immutability of index images at the moment and the way that you add to them rather than change them, but I do see the use case.
So to be clear, right, this would not be modify the image. This would be you're going to build a new image with that metadata.
Yeah, absolutely. No, I get that, but the fact that that capability doesn't exist kind of makes the images reasonably kind of additive only. And I feel like we might lose something by moving away from that, but then, yeah, there's definitely valid use cases here. So we would rebuild the image time from the declarative config, yeah?
Yeah, that's exactly. Basically, I think what we should be clear about here is the default workflow should, as much as possible for pipelines, try to retain the additive format. I think what you just described is exactly what we liked about it and the reason we built it that way, which was, I mean, the very fundamental reason is you don't really want to remove an index image or remove a bundle from an index, because if you do that and somebody has already installed your thing and you've removed the edge metadata around how to get from that thing to another
desert
thing.
island, yeah,
Exactly. And so this declarative configuration, it is something that if you're doing it, you need to be aware of how it works, and you need to, like, here be dragons, go make your changes, because opting, like, basically we're giving you a release valve for handling stuff that like normal users were still expecting to use. Just add more stuff, always keep adding, and don't have to worry about modifying this at all.
Yeah, I'm wondering if there's kind of a builder style approach we should be kind of looking at from here, in terms of at the moment the way that we build up an index image is we run OPM on it, and then we run OPM again to add another one, and again to add another one. It's similar to how Builder kind of put together a shell script for building an image. You kind of expect it to be added to at the end, but actually that's the declarative format in a way. Rather than having to define a new format, we could just say, well, the declarative format for building an OPM, for building an index, is to run OPM, this command, this command, this command, this command. You can go back and edit that script.
It's interesting.
That might be getting more into implementation detail than feature, but
So I think it's valuable though. So I think one of the things that we're actually thinking about here, like there's some other nice things we get from having this declarative configuration, which is basically you don't need to keep track of historical index images. You don't need to pull down the old thing. If the storage for the context of the config is the file itself, you can just put that thing in source control. And then whenever you want to add something, you just modify that file and then rebuild from scratch, tag that as latest, and that is your index. So you don't have to pull anything before.
I should also note that another big, I guess, thing that you get from this is the ability to provide overlays of different properties for bundles. So you don't need to republish a bundle in order to get that property to change.
So you're saying if there's something wrong in the bundle itself, you could just fix it in the index image?
Or let's say more like channels. Like I wanted to move this bundle from this channel to another channel, or something like that.
Yeah, I think
Right.
what we're talking about is the recognition that there are certain properties about bundles which are actually not metadata about the bundle itself. I don't like what this is not doing is it's not giving you a way to go modify the YAML for installing that bundle. What it does is like, at the index level kind of questions that are now just sort of implicitly being defined by temporal information about when you added the bundle. Just kind of like no longer apply. Like if you can go and modify those bits, then you don't have to go and rebuild bundles whenever you want to change something about like where it is in the graph or what graphs it's in.
I think the motivating example that I always keep in mind is promoting one operator bundle between channels. So like I've already published it and now I just want to move it into another channel as well. Today, that's annoying. So you have to rebuild a bundle with different sets of metadata on it.
Yeah, I've never had to do that. I've always assumed that if I needed to do that, it would just be easy, but it sounds like it's not.
It is not.
It'd be handy, Evan, I guess, if you could put the use case inside this feature request so we can remember some of the motivations there. Maybe that's what's in this enhancement PR.
Yeah, so there's a bunch of stuff in this enhancement. I think there's still a lot of churn going on in here. And I still think we probably need to add some more of those kinds of things. But there a lot of that I think is already in here. So if you take a look at this and there's still stuff missing, feel free to comment and we can probably update it to include all of that. I also think this is just all really a work in progress and we're going to continue to churn until we get exactly the thing we want.
Does this have any cascading effects on the interface of the index image itself, like to a subscription or a catalog source?
So in the short term, the answer is probably no, because we need to make sure that this is backwards compatible for a while. I think there's a couple of things. So there's also this. That's another thing that we should probably bring up around this and what we're trying to accomplish is that like there's two other things that are kind of not nice about the registry project right now because of compatibility reasons, which are the SQLite database living inside of the index. I think what we're talking about here is removing SQLite entirely from the index image and replacing it with just this file format, so that we won't have two layers of interaction. I don't think that part's going to necessarily happen right away. I think that's sort of the medium-term goal. The long-term goal is, I think, based on what we've just been talking about for a while, is remove the gRPC API as well. Because there's a lot of problems with the way that the way that OLM and specific versions of OLM interface with specific versions of that database and that API. And so there's like a compatibility layer now between like 4 different things. And by just turning it into a file format that OLM pulls down and uses directly, that should simplify that as well. That one is, I think, even a little bit further out because OLM for a while will probably need to be able to still interface with the gRPC API, and the registry will probably still need to serve the gRPC API for older versions of OLM. So we're going to need to talk about, deprecation strategy around all of that stuff.
Cool. And then the other question I had as we were talking about this, thinking about the pipeline scenarios, have we talked about, like, is there going to be just one JSON file per index, or are we talking about like one per package, or like is there some sort of notion of a composite index where to add a new package to an index, like, oh, just add that package's JSON file or whatever?
It's a good thought.
Yeah, I mean, I think we've. Sorry, go ahead.
I was just gonna say, like, there's definitely nothing. Like Kevin said, this is all still churning a lot, but that's a problem I've been really interested in, and I've been trying to sketch out some things for how that could work. So far, it's actually been kind of hard to write down the full problem space because this touches so many different aspects, and we have so many different concerns. So like publishing concerns, what does it mean to take like a package from two different catalogs and combine them into one? Obviously, all of the normal concerns we have for just providing this information to dependency resolution. We have the ability for users to come in and add properties and remove properties from packages in the index. It's just been kind of a lot to write down, but that problem is something I'm really interested in. And it's making me, at least right now, think that we want this declarative index config to be like a JSON file, but then potentially some underlying format, file system structure, something along those lines that is the more standard interface for people to write into, that then gets compiled into the declarative config that's just the JSON blob. It would be totally optional because the JSON blob is what we use, but I think there's a lot of advantages to having some directory structures. Then, just copy my package directory and plop it over in this other index, and now I've copied my whole thing over without needing to cut and screw JSON blobs. But like I said, still lots of churn.
Yeah, but the idea of splitting up packages is very attractive from my perspective because of the nature of doing air-gapped restricted network style installs, where at the moment I think the tooling is kind of focused on mirroring a whole catalog, but it's really hard to get a catalog that matches what you need it to match. So if we could put one of our operators and all its dependencies in one catalog by mixing up declarative configs, that would make our lives very easy and help solve that problem.
Yeah, that's a good point. And that workflow should probably involve the resolver as well, so that you don't have to manually decide what your
I mean, even if to start with, what we had to do was produce all of our catalogs with the dependencies in for people to use, and that will be a good start. If the dependency resolver could do that for us, and then we could just say, okay, dependency resolver, go to that catalog and pull out this operator and its dependencies, then that would be the ideal for us. Yeah. So where do we capture those use cases then? Do we put those on this RFE, or do we put those in the enhancement?
So I think if you have comments, I think if what you want to do, I think what you want to probably do is, if you look at that enhancement and you feel like something's not getting captured there, I would make a comment there so that we can update the enhancement. I think that's probably going to be more where like implementation detail kind of stuff, or at least closer to the implementation, will show up. I think the RFE would be more like, I disagree that we should do this or whatever.
Okay, cool. I will try and put some words in there to capture some of the things we discussed here, because I think they're important.
Cool, thank you. All right, does anybody have anything else on this one? Nope. Okay. So that's everything for the upcoming releases that we've currently marked. So there's a bunch of other stuff here in the agenda. We only have 3 minutes left. So I guess anybody who has added anything to that backlog milestone section, if you have one that's got a TLDR that we can discuss in the next, 180 seconds, feel free to bring that up right now. Otherwise, we might want to just call it and then talk in 2 weeks.
Yeah, I guess this is Chris. I've created most of these, obviously. I did create that top one based on our previous discussion. So I think that's a to-do for you, Kevin, to create that version 1.0 RFE and how we're going to do that and all the crap that goes around that and all that kind of stuff. At least I boiled it down to that. I think the other one that's important is the bottom one, the formalized air gap support, right? So that's something that we're tackling. We have a lot of customers who really, really, really want this. And so I've just kind of combined a whole bunch of things that are related to that. Like for example, being able, when you're air gapping, how do you preserve the tags when you're also doing digests in the related images for the operands and the operator. Curated catalog work, which I had created an enhancement for several months ago, which I just haven't had a chance to dive into yet. And we've got some features that support pieces of this today. And then some use cases around how customers actually want to do air gap, whether they have Bastion servers, if they have a laptop, or should they bring from their private to public network, or they want to capture all of the images and the metadata independently, and then move the data around from compute device to compute device. So this is something that James and I are interested in, and so we're going to probably formalize this, and maybe we can bring this up at our next OLM meeting. But I wanted to bring it forward.
Yeah. So I mean, I'd have to look at all of these things. So right now, I mean, the only major like air gap work that we have, like as an OLM group, have done, has mostly been to support OpenShift to be able to like ship these kinds of things.
Yep.
Which, we've sort of done like the MVP approach to doing that. I think if we want the Upstream project to more formally support a lot of these workflows, probably what we need to do is at the very least, like sketch out what that should look like on an Upstream Cube cluster, and then come up with like, well, here, what are the warts and what's missing? It seems like you've already done the beginning of that. So I'm wondering if we can kind of like aggregate all of that into like a living document somewhere, like maybe we create a Google Doc or something that sort of outlines the current, like maybe what the current workflow looks like and what's missing. That might be like the best way to frame it.
I mean, we can tell you the workflow that we have. It's not the workflow that we'd like, but we can definitely go into a lot of the pain points that we've seen from our experience.
There's that, and then we do have some concrete use cases from our customers too, which will help drive, the correct solution. So, yeah, we definitely could collect that into a centralized spot for discussion.
Yeah, that seems really valuable.
I do just want to point out that at least right now, I think that the air gap support is essentially OpenShift only. So it's probably not something for the Upstream working groups. It's tricky. There could totally be a good way to do this upstream. The problem right now is that at least I'm not aware of any equivalent to the image content source policy that OpenShift has, and or some way to like generically affect mirrors across all CRI implementations. Like ICSPs just generate mirroring for cryo specifically. So I'm not sure how we could do this generically over any instance of an Upstream kube cluster with some, using container D or Docker shim or something like that.
Well, even if we don't, right, we still need features within OLM Upstream to be able to even support OpenShifts of doing that. And so I still think that we need to document centrally something, right? And then we have to divide and conquer.
I agree. I guess I'm suggesting that there's probably not much we can do to enable air gap support upstream right now without going to maybe like some of the SIG node meetings and saying like, how can we do this across, any CRI implementation, for example?
Yeah. Do we know if there's any Kubernetes SIGs looking at disconnected clusters at all? I can look into it.
There was an operator framework air gap SIG, but that kind of disappeared after about 4 meetings. So I'm not sure.
Yeah.
what's going on.
I imagine that's because Operator Framework said, oh, well, this isn't a problem anymore because OpenShift is solving it for OpenShift, and then we don't care that much.
And OpenShift's the only people who raised it.
Yeah.
Okay. Cool.
All right. Well, I think we're already over time, so I'm gonna stop the recording here.